Greetings everyone, we will continue our discussion on programming for problem solving using C. In the previous session we have started about the pointers and we have discussed about what are pointers to pointers and pointer compatibility. In this session we will be looking about the pointer arithmetic and arrays and relation of your arrays with pointers and also array of pointers. So first we will be looking about pointer arithmetic. So when you are performing pointer arithmetic, the following statements are valid statements. That is, you can perform the following arithmetic operations on pointers. That is, you can add an integer to your pointer, you can subtract an integer to your pointer, and you can perform the subtraction of two pointers of same data type. Remember, you cannot perform all the arithmetic operators, you can perform only these three arithmetic operators. That is, you can add one integer to your pointer, you can subtract an integer from the pointer, and you can subtract two pointers of the same data type. But remember, you cannot add two different pointers. So first we will be looking about this thing. In order to better understand what is the pointer arithmetic you are trying to do, so you have to understand the what is the structure of your machine, whether you are using a 16-bit machine or a 32-bit machine. If you are using a 62-bit machine, you should know your size of your particular data types. Your basic int will be 2 bytes and your char will be 1 byte. Your long float will be 4 bytes. Double and long double, they will be of 8 and 10 bytes respectively. But remember this particular size of data type will be affecting your pointer arithmetic. When you are going for a 32-bit machine, your integer will be of 4 byte. And character will be of 2 bytes, and your long and float will be 8 bytes, and double will be 16 bytes. Okay, so these are your various size of the data types while you are using a 16-bit or a 32-bit machine. So when you are performing your pointer arithmetic in a 16-bit or a 32-bit machine, you have to remember that we can perform three operations: addition of integer, integer value, subtraction of integer with pointer, and subtraction of two pointers. Two same type pointers. Remember, same type pointers. Subtraction of two same type pointers. This is an example to know what are the types of pointers. So we have initially given variables. To better understand this, I will be telling you first how you can understand these pointers, then we can go for the actual implementation of your addition, subtraction of pointers. First, here you are having a basic pointer P1. So next time I am having a variable M. M contains the value 5. P1 contains the address of M. P1 contains the address of M. Then there is a P2, and P2 contains the address of N. N is having the value 10, and you are having another variable O. O is having value 0. And you are having another pointer P3, and you haven't initialized anything. So to better understand what is pointer arithmetic, let's take your memory in this manner, where your M is present at one memory location. Let's take it as some 1000, and you will be having 1001, 1002, 1003 like this, consecutive memory locations. In a similar manner, you will be having other memory locations. 1004, 1005 like this. You will be having your memory locations. So when I say P1 is equal to address of M, so P1 will contain the address 1000. P1 will contain the address 1000. Why? Because address of M is 1000. It contains the value 5. So pointer arithmetic means you can add an integer to the pointer. That is, you can perform something like this: P1 is equal to P1 plus 1, or you can perform P1 is equal to P1 plus some random value n. Okay, you can perform pointer arithmetic, that is you can add an integer to the pointer, that is you can add 1 or you can add 5. To simplify this one, you can increment the pointer like this, p1 plus plus. p1 plus plus is same as your p1 is equal to p1 plus 1, and you can increment the same thing 5 times, it is p1 plus 5. What will happen is, since this is an integer pointer which is pointing to an integer, when I try to increment your integer pointer, it will point to the next integer in your memory. That is, it will point to the next integer in your memory. So your M will occupy 1000 to 1003. Your M will occupy 1000 to 1003. Why? Because it is a 4 bytes memory. If you are using a 32-bit machine, if you are using a 16-bit machine, only 2 bytes. If you are using a 32-bit machine, 4 bytes. Now if I increment p1 plus plus, initially it is pointing to M. When I increment, it will point to the next memory for your integer. Now p1 will contain 1004. Okay, p1 will contain 1004. If I increment again, now p1 will contain 1008. So like this, if I keep incrementing my particular pointer, I will be going to the next memory location. Even though this particular memory locations might not be used in your program. Okay, when I perform my pointer arithmetic, that is, if I take a pointer and point it to one of the integer, and if I increment, I will go to the next integer value. Okay, if I again increment, I will go to the next integer value. Like this, I can have a pointer and keep incrementing to get to the next integers in your memory. Okay, so this will be calling it as pointer arithmetic. The same is the case if I decrement the pointer. That is, if I decrement the pointer, previously it was pointing to 1008, now it will point to 1004. Decrementing the pointer means going backside in the memory. Okay, going backside in the memory. Now it will be decremented by 4. If you take another data type, the particular based upon the size of the data type, the incrementation or decrementation will happen. Okay, so if based upon the particular data type, the incrementation or the decrementation will happen. That is about your addition of an integer and subtraction of an integer. So in case if you are performing p1 plus 5, okay, initially if p1 is 1000 location, p1 is present at 1000 location. If I am performing plus 5, what will happen? Okay, 5 means I have to go to the next fifth integer. So it will be 5 into 4, 20 bytes. So it will be pointing to 1020 now. Okay, it will go to the fifth integer in the memory. So it has to move 5 locations. So now it will be pointing to 1020 memory location. In this manner, your increment or decrement will access your memory and move to the next location in the memory. So that is about addition and subtraction of an integer to your pointer. If you continue with this example, you remember P1 is pointing to M and P2 is pointing to L. So initially you have printed those addresses, that is P1, you have printed the addresses, that is P1 and P2. Now you are performing something, O is equal to star P1 plus star P2. So star P1 means value at the address of P1, whatever may be the M value at the address of P1 means indirectly M, value at the address of P2 is N. Okay, so if you see in the example, M value is 5, N value is 10, M value is 5, N value is 10. So indirectly P1 is pointing to M and P2 is pointing to N. So indirectly I am referencing M value and N value. So they both will be added, and now your O value will be 15. O value will be 15. That is the statement here, and you are printing your O value. It will be printed as 15. Next, this is the subtraction of two pointers. P3 is equal to P1 minus P2. So this is a valid statement. What is the meaning of this statement is, okay, In order to perform the subtraction of two pointers, they should be of the same data type, since P1 and P2 are of the same data type. And if P1 is pointing to 1000th memory location and P2 is pointing to 2000th memory location, okay, P1 is pointing to 1000th memory location and P2 is pointing to 2000th memory location. So the difference of the pointers will give you the number of elements between the pointers. Okay, the difference of the two pointers will give you the number of elements of that particular data type between those two pointers. For example, your first pointer is pointing to 1000 and your second pointer is pointing to 2000. It will give the number of, and this is an integer pointer, it will give the total number of integers present between these two pointers. Okay, how many number of 4-byte elements are present in this gap? And to simplify, if P1 is pointing to 1000 and if P2 is pointing to the next integer location 1004, okay, it will be pointing to the next integer location 1004. The difference will give you 1004 minus 1000. So this will be 4, that is 4 by 4, that is 1 byte is 4, sorry, one integer size is 4, you will be getting the 1 value. So 1 is the total number of, that is in between 1000 and 1004 you are having one difference. So we will be getting the result as 1. Okay, we will be getting the result as 1. So between these pointers, that is P1 and P2, we will be getting the total number of pointers present. Okay. Next, P1 plus plus, as I already told you, it will point to the next integer. P2 minus minus, whatever may be the address, it will point to the previous integer. And P1 plus P2. Okay. So P1 plus P2 is not a valid statement. Why? Because the addition of integers is not valid. Why? Because if I add 1000 and 1004, you might be getting 2004. The 2004 location might not be a valid location. You will be getting an error for that one. So only 3 operations are valid for your pointer arithmetic. One is incrementation operation. Based upon your data type, it will go to the next element in your memory. Decrementation operation, based upon your data type, it will go to the previous element in your memory. And subtraction operation, that is difference operation. If I perform the difference between two pointers, it will be giving you the number of elements present between those two pointers. Okay, these are the operations which can be performed on your pointers. That will be about your pointer arithmetic. Next, coming to pointers and arrays. So how pointers and arrays are related? So when an array is declared, the compiler allocates sufficient amount of memory to contain all the elements of your array. For example, if I declare this array, I will be declaring something like this: int ARR of 5. If I perform this declaration, what will happen? The memory will be assigned in this manner. That is, it will be allocated 5 memory locations, sufficient memory to store 5 data values. The elements are ARR of 0, ARR of 1, 2, 3 and 4. Those will be your indices. And the addresses are from 1000, 1002, 1004, 1006 and 1008. Here you have considered a 16-bit compiler where you will be having 2-byte integers. So the first byte will be present at 1000, that is the second element will be present at 1002. Okay, in this, the base address of the first element of the array is allocated by the compiler. So the address of the first element, that is 1000, is also allocated by the compiler. So the 1000 element will be calling it as the base address of this particular array. Okay, the 1000 address will be calling it as the base address of the array. Now with this, what is the relation of your pointers and arrays? The name of the array acts as a pointer to the base address. Okay, what is the name of the array? ARR will act as a pointer to the base address, that is ARR will contain 1000 by default. That is ARR contains the address of the first element in the array. Okay, as you already know, we will be having pointers. Only pointers will contain the addresses. Okay, pointers will contain the addresses of some variables A. So PTR will contain address of A, so that variable may be anything. Now ARR is also a pointer like thing, and it will contain the address of the base element. The address of the base element. So ARR will act as pointer to the first element in every array. So the name of the particular array will act as two purposes. That is, it will have two purposes. The first is it acts as the name of the array. The second is it acts as pointer pointing towards the first element in the array. Okay, your name of the array will act as pointer to the first element in every array. Okay, when you declare an array, okay, now A is not only a name of your array A, it also contains the address of the first element. It also contains the address of the first element. ARR is equals to address of ARR of 0 by default. You need not do anything. Always this thing is valid. The name of the array will act as the pointer to the first element. So we can also declare, so that is about your relation between your pointer and your array. You can also declare a pointer to an array. That is, not only your name of your array acts as your pointer, you can declare separate pointers which will be pointing to your array. For example, you are having your general pointer P. Now you are having your array ARR of 5. As you know, the name of the array is a pointer, so you can directly assign your name of the array into P. That is, now P also will become pointer to the array elements. So what is happening here? If you are having your array like this is the 0, 1, 2, 3, 4. Your name ARR is pointing to the first element. In the same manner, since you have assigned your name to your another pointer, now P also will be pointing to the first element. Now we are having two pointers. One is the name of the array which is pointing to the first element, and a new pointer P which is a pointer to the array is pointing to the first element. Now we can access every element of your array by performing P++ to move from one element to another. Now P is pointing to the first element. If I increment P++, now it will point to the next element. If I increment, it will go to the next element. This is where your arithmetic or pointer arithmetic will come into hand. So if you keep incrementing the pointer, I can go from the starting of your point array to the ending of the array. Okay, this is how you can implement your pointers to an array. So this is another example where you can, same example what you have discussed so far. You are having an array A which is having values 1 to 5, and you are having a pointer which is pointing to A. You have written n star P is equals to A, where A is the name of the array and this is a pointer. You have assigned your address whatever that is present to P. Now A array is there, and this is 1, 2, 3, 4, and the values are 1, 2, 3, 4, 5. You have given 1, 2, 3, 4, 5 values. Now since you have done this, P will be pointing to the first memory location. So I am starting from 0 to 5. I will be printing all the values. That is, now star P means it will print value at the address of the first location, that is 1. It will print this value. When I increment P++, it will point to the next memory location. Again, if I do star P, it will print this value. Like this, you are repeating in the loop to print all the values in your particular array. This is how you can have a pointer to the array and access all the elements that are present in your array. So the generalized form of using your pointer with an array is, if your name of your array is ARR, and if I want to access an ith element, ARR plus I, you can use. What is this meaning? If this is your ARR array and this is 0th location, first, 2, 3, 4. Okay, so if these values are 10, 20, 30, 40 and 50. So if I want to access the first location, what I need is star ARR. As you already know, the name of the array will act as a pointer. Star ARR means it will be value at the address of ARR. Value at the address of ARR will be the first memory location. Since ARR is pointing to the first memory location, value at the address of ARR is the first memory location value, that is 10. Okay, in a similar sense, if I want to go to the fourth memory location, what I have to do? Last memory location, I can do ARR plus 4. Okay, ARR plus 4. ARR plus 4 means it will move 4 memory locations, 1, 2, 3, 4. So now it will be pointing to this particular position. Now your array pointer can be present as the fifth memory location. So you are not incrementing any pointer here. So you can access all the elements in your array by using the array name and by adding index by using the pointer. Okay, in this manner you can access any element in your array. So which is same as your ARR of 5. This is same as ARR of 4. So this is how your pointers can be used to access any memory location in your array. Okay, you can use your array name and add the particular values of the index to get your particular value present in the memory of your array. So in the similar manner you can have pointers to the character arrays or your strings. Okay, I think you know your string is nothing but a single dimensional array where each character will be present in one memory location and which is terminated by the null character. So if you remember, this is a pointer. So this is a string, and if you are having char str of 10, so this is a single dimensional array. So single dimensional string with 10 characters, this is how we can implement it. So by default str will be acting like a pointer. Okay, by default, as you have seen in the previous slides, your name of the array will act as a pointer to the first memory location. The same thing is applied here, where you can use, okay, the pointer can be used to create strings as well. So char star ptr, this is a character pointer, so it is a string. We can assign it in this manner. What will happen? The above code creates a string and stores its address in the pointer variable str. What will happen now? Str will point to the first memory location. Okay, that is the first character. Str will point to the first character. If I keep incrementing the str, I can go to all the memory locations and I can access the complete string until I reach the null element. Okay, until I reach the null character. So this is how you can use your pointer to access the string as well. So accessing the strings by using pointers is much easier compared to what you have done without using pointers. So creating the strings is much easier and accessing all the elements in the strings will be much easier by using your pointers. So we can also have, this is the last topic of this session, array of pointers. We can also have an array of pointers. So pointers are helpful for handling character arrays with rows of varying length. So we will be having an array of characters, two-dimensional array of characters, or array of strings, which you have seen in the previous sessions. You will be having array of strings. When you are handling array of strings, your array of pointers will be much useful. This can be understood with an example. So this is an array of pointers. This is an array of strings. So both are same. In an array of pointers, if you see, you have created a pointer, and this is an array of 3 strings. Array of 3 strings. This will array name of 0 will point to Adam, name of 1 will point to Chris, name of 2 will point to your Daniel. Here if you see, this is an array of strings where the first string can contain 20 characters, the second string can contain 20 characters, the third string can contain 20 characters. This you have seen in your strings. Okay, this can be implemented by this much easily, and you are having better memory implications as well. So if you see conceptually the same thing, you can understand. So this is how it will be implemented by using pointers, and this is how it will be implemented without using pointers. So as you have seen the declaration, we are having 3 strings where string is each of 20 character length. Each of 20 character length. So how your memory will be assigned? It will be assigned for 20 characters. Okay, it will be assigned for 20 characters. So even though you are storing only 4 characters, the remaining 16 characters will be of a waste of memory. Okay, the remaining 15 characters will be of a waste of memory. So each and every string what you are trying to store, there will be a lots of amount of waste of memory. But if you use a pointer by your string, so the first pointer will point to Adam, that is it will point to this element, that is name of 0 pointer will point to this element, name of 1 pointer will point to the second element, name of 2 will point to the third element, name of element will point to the third string. In this implementation, you haven't specified the size of your string, and the pointer will point to only the first element. If you keep incrementing the pointer, you can go from the starting of the string to ending of the string. But here you have specified the size of the string, so it has to go for minimum, it has to assign 20 characters for each and every string. But here there is no space implication to provide 20 characters. Whatever may be the number of characters, it will be stored, and the first memory location will be pointed to by your pointer. So only 3 locations for pointers, which will point to the first character of their respective strings. If you see, you will be having 3 memory locations for your pointers, and each pointer will point to the first memory location of your string. So this is how you can have array of pointers. So here you are having 3 pointers. This is the array of pointers pointing to your strings, and which will save your memory. So your arrays and pointers are related in this manner, and your pointers can be used to specifically with strings for better manipulation operations. In the next session, we will be looking about some more topics of your pointers. Thank you.